right, Algebra 1, last section before we test. We're working on some word problems. We're in Lesson 5, 13, Chapter 5, Section 13, and we're using factoring to solve problems. Our essential question is, can you solve problems by writing and factoring quadratic equations? We're back to these two consecutive integers. It says find two consecutive negative odd integers whose product is 255. Well, if the product is 255, I need two consecutive odd integers. We'll deal with the negative in just a minute. If I have odd integers, remember, if I'm looking at odd integers, they are 2 units apart. Let's talk why. 1 plus 2 is 3. 1 plus 4 is 5. 1 plus 6 is 7. These are our odd integers. So remember, the odd and evens both go up by 2, 4, 6. Remember, regular just consecutive integers are just x plus 1, x plus 2. So at this time, they're asking us for two consecutive odd integers. So x times x plus 2, and the product is 255. Well, I know that all quadratics have to be equal to 0. So the first thing I'm going to do is distribute. X squared plus 2x equals 255. And now I'm going to get this 255 over. And I know it can't be added, so here I am setting up a trinomial in which I can factor. But I do have to find the factors of 255. The factors of 255 that add up to be 2. Well, I know that 17 times 15 is going to add up to be 2 and multiply to be 255. In this case, subtract to be 2. So I know that I have x plus 17 and x minus 15. Well, right here, if I solve this, x plus 17 equals 0. When I subtract 17, it looks like I get my negative integer. Didn't it ask for a negative integer? And when I go ahead and solve over here, x minus 15 equals 0, I don't get a negative integer. So because I don't need a positive integer, I'm not going to use that. But I do have to answer the question. It says find two consecutive negative odd integers. Well, if the first one is negative 17, when I add 2, I have negative 15. And I just checked this on my calculator. If I multiply negative 17 times negative 15, do I get a positive 255? I do. All right, moving on. The length of a rectangle is 6 centimeters more than 3 times its width. You know what I'm going to tell you. I always tell you the same thing, draw a picture. So I know the length of a rectangle is 6 more than 3 times its width. If I call W its width, 3 times its width plus 6 will be the length. It tells me the area is 144. Well, in order to find the area, don't I have to multiply W and 3W plus 6 to get that 144? I do. So again, we're going to set up that quadratic function. Let's distribute 3W squared plus 6W minus, equals 144. Sorry, I'm trying to move quickly. So I do have to subtract that 144 over to make it equal to 0. All quadratics have to be equal to 0 to move on, to solve them. All right, so right here, I probably could factor out a 3. When I factor out a 3, I have W squared plus 2W minus 48 is equal to 0. Well, this can continue to be factored. What are the factors of negative 48 that add up to be 2? Good. We have a positive 8 and a negative 6. So a lot of people ask me, well, what do I do with this 3? I'm just going to show you. If I divide 3 into 0, wouldn't that just cancel out and just be 0? It would be. So I can just ignore the 3 as long as there's no variable. If there was a variable, we would have to deal with it. And now I'm going to go ahead and solve. If I have w plus 8 equals 0, when I solve, I get a negative distance. Can I have a negative distance in life? No. So we're going to reject that one. And when I have w minus 6 equals 0, and I add 6, can the side of a rectangle be 6? Yes, it can. So I'm going to go back here, and I'm going to say, hey, w is equal to 6. So if I have w is equal to 6, well, 3 times w, which was 6, I'm just plugging this 6 in for the w using substitution. So I have 18 plus 6, which is 24. So they said to find the dimensions of the rectangle. I know this rectangle is 24 by 6 centimeters.